The universe can be imagined as an endless symphony, a vast performance where every star, planet, and moon contributes to a cosmic rhythm woven across space and time. Among all the wonders scattered through this immense expanse, few discoveries have captured human curiosity more deeply than exoplanets, worlds that exist far beyond our own solar system. These distant planets are not simply objects in space. They are entire realities, each with its own environment, chemistry, and mysteries waiting to be uncovered. The study of exoplanets is still relatively new in the history of science. It was only in 1992 that astronomers confirmed the existence of planets orbiting another star, forever changing humanity's understanding of the cosmos. Since then, thousands of exoplanets have been identified, with many more candidates still awaiting confirmation. Yet even these discoveries likely represent only a tiny fraction of what truly exists. Scientists now believe that the Milky Way galaxy alone could contain more than 1 trillion planets. The scale is almost impossible to comprehend. If every planet were represented by a single grain of sand, the total would create landscapes larger than any desert on Earth. Within this enormous population of worlds, many are thought to be rocky planets similar in size to Earth. Some orbit within regions known as habitable zones, where temperatures may allow liquid water to exist. Water is considered one of the essential ingredients for life, making these planets especially important in the search for living systems beyond Earth. This raises one of the most profound questions humanity has ever faced. Is life unique to our planet, or could it emerge naturally wherever the right conditions exist? Among all known exoplanets, one world has drawn particular attention from scientists and astronomers. Proxima B. This planet orbits Proxima Centauri, the closest known star to our solar system, located about 4.2 light-years away. On a cosmic scale, that distance is incredibly close. Compared to galaxies billions of light-years away, Proxima B exists practically within humanity's local neighborhood. Even so, the limitations of modern technology make it unreachable for now. Using the fastest spacecraft ever built, a mission to Proxima B would still require tens of thousands of years. What makes Proxima B especially fascinating is its location within the habitable zone of its star. In theory, temperatures there could allow liquid water to survive on the surface. However, the planet itself is far from Earth-like. Proxima Centauri is a red dwarf star, smaller and cooler than the Sun, but also far more active and unstable. Because the planet orbits so closely to its star, one full year on Proxima B lasts only about 11 Earth days. Scientists also believe the planet may be tidally locked, meaning one side permanently faces the star while the opposite side remains in constant darkness. Such a world would experience dramatic extremes. One hemisphere could endure endless daylight and intense radiation, while the other side might remain frozen beneath perpetual night. Between these regions may exist a narrow twilight zone where temperatures are more balanced. Some researchers speculate that this thin band between heat and darkness could offer the most favorable conditions for life. If someone could stand within that twilight region, the sky would appear unlike anything seen on Earth. The star would remain fixed in one position, never rising or setting. One horizon would glow beneath constant light while the other faded into endless darkness. Powerful winds might sweep continuously across the planet as heat from the illuminated side moved toward the colder regions. Instead of seasonal weather patterns, the atmosphere could be driven by permanent temperature imbalance, creating storms and climate systems unlike anything in Earth's experience. Despite these harsh conditions, Proxima B remains one of the most compelling worlds ever discovered because it combines possibility with proximity. Unlike distant exoplanets that feel abstract and unreachable, Proxima B exists close enough to inspire realistic hopes for future exploration. It represents a destination that future generations may one day study in far greater detail. Modern astronomy has already transformed the way scientists investigate distant planets. Instruments such as the James Webb Space Telescope allow researchers to examine the faint light passing through alien atmospheres. By analyzing this light, scientists can identify gases including water vapor, methane, oxygen, and carbon dioxide. These chemical traces act like fingerprints, revealing the composition of worlds that no human has ever visited. There have also been moments that sparked curiosity and debate. In recent years, unusual radio signals were detected from the direction of Proxima Centauri. The signals appeared narrow in frequency, a feature sometimes associated with artificial sources, although natural explanations remain far more likely. The signals did not repeat, and their true origin remains uncertain. Even so, discoveries like these demonstrate how little is still known about nearby star systems and how easily new data can challenge existing assumptions. Another area of scientific speculation involves the possibility of detecting artificial light on distant planets. In theory, an advanced civilization might illuminate the dark side of its world with technology powerful enough to be observed from across interstellar distances. Although such detection remains beyond current capabilities, future telescopes may eventually become sensitive enough to search for these faint signs. If evidence of artificial illumination were ever confirmed, it would become one of the most important discoveries in human history. Proxima B therefore represents more than a distant exoplanet. It has become a symbol of humanity's expanding awareness of the universe. It stands at the meeting point between scientific observation and imagination, where measurable data blends with deeper questions about existence and life beyond Earth. As research continues, astronomers will keep discovering new worlds, each more unusual and extraordinary than the last. Some will be frozen wastelands, others covered by violent storms or oceans unlike anything found in our solar system. And perhaps somewhere among them are planets where life has already emerged beneath alien skies. In the end, the exploration of exoplanets is not only about searching for another Earth. It is about understanding the immense diversity of the cosmos itself. Every discovery reminds humanity that reality is far larger, stranger, and more complex than once imagined. Somewhere within that immense ocean of stars, Proxima B continues its silent journey around its distant sun, waiting for the day when humanity finally learns more about the world hidden in the darkness beyond our own. As telescopes improved, scientists began to realize that planets are not rare exceptions in the universe. They are natural outcomes of star formation. Wherever stars are born from collapsing clouds of gas and dust, planets often emerge beside them. Entire solar systems form as part of the normal architecture of the cosmos. This discovery transformed humanity's understanding of existence. Earth was no longer seen as the center of planetary creation, but as one example among countless worlds spread throughout the galaxy. Among the greatest mysteries surrounding exoplanets is the question of habitability. Scientists searching for life do not simply look for planets identical to Earth. Instead, they search for environments capable of supporting chemistry complex enough for biology to emerge. Liquid water is considered one of the most important ingredients because on Earth every known form of life depends on it. Yet water alone is not enough. Atmospheres, magnetic fields, geological activity, and stable temperatures may all play crucial roles in determining whether a planet can remain suitable for life over long periods of time. This is why red dwarf systems such as Proxima Centauri remain both exciting and uncertain. Red dwarfs are the most common type of star in the Milky Way. They burn slowly and can survive for trillions of years, far longer than stars like our Sun. In theory, this immense lifespan gives planets orbiting them vast stretches of time for life to potentially develop and evolve. However, red dwarfs are also highly volatile. They frequently release intense stellar flares capable of flooding nearby planets with radiation.